Fix search typos and return the right product fast. By the end, you will have a working spelling corrector for search. You will generate plausible candidates, rank them by how many edits they need, and return a safe correction under a distance limit. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Spelling correction matters because it improves recall and reduces zero-result queries. The core metric we optimize is closeness under edit distance, which correlates with relevance for short queries. The main trade-off is latency and candidate set size. More aggressive searches mean more CPU and more memory. This approach works well for catalogs of a few thousand entries and for user queries that are short words. It can struggle with long phrases or phonetic errors. The idea is simple. Edit distance counts the minimal edits to transform one word to another. We will use that distance to score candidates. It shines when typos are small and users type roughly the right prefix. It has a limitation. It ignores meaning and pronunciation, so it is best combined with other signals later. Here is the exact thing we will build and see in action. A pipeline that computes edit distance, generates one edit candidates, ranks the top 3, applies a prefix filter, and finally returns the best correction under a max distance. Now we compute the exact distance between two tokens. This snippet computes the exact Levenstein edit distance between two words. It walks through one word and the other and counts insertions, deletions, and substitutions needed to turn one into the other. The paragraph shows how the algorithm fills a small table of costs and reads off the last cell as the distance. This gives an exact interpretable number you can use to rank candidates. It is cheap for single comparisons, but becomes heavier as you compare one query against thousands of entries. Use it for scoring and verification, rather than scanning the entire catalog live without indexing. Next, we generate nearby word variants and check them against the vocabulary. This snippet generates all one insertion edits and intersects them with a vocabulary to find plausible candidates. It systematically inserts each letter at each position to create variants, then keeps only those that appear in the product title list. The result is a small candidate set that often contains the intended word for a single typo. If you change the edit radius from 1 to 2 edits, you will find more candidates, but the cost rises a lot and false positives increase. This trade-off is the classic precision versus recall decision in spelling correction. Then we rank the surviving candidates and pick the top few. This snippet ranks candidates by edit distance and shows the top 3 results for the query. It computes the distance for each candidate and sorts by that score, breaking ties by a secondary signal, such as frequency, when available. The output is a short list you can show to users or use for automatic correction. The adjustable parameter here is the number of results to return. Returning more increases coverage, but also the chance of showing irrelevant suggestions. For UI use, 3 candidates is a common sweet spot between helpfulness and clutter. Next, we narrow candidates using a prefix constraint before sorting. This snippet filters candidates by a 3-letter prefix before ranking by edit distance. It first checks that the candidate shares the first 3 characters with the query, then applies the distance ranking. The prefix filter dramatically reduces the number of distance computations, cutting latency for large vocabularies. The downside is that if the user typed the prefix with the error, the correct term may be filtered out. The main tutable is prefix length. Longer prefixes speed things up, but risk missing corrections. Shorter prefixes keep recall high, but cost more compute. Finally, we cap allowed distance and return a single correction if safe. This snippet returns the best correction under a max distance threshold. It inspects the top-ranked candidate and only accepts it if its distance is less than or equal to the configured maximum. If no candidate meets the threshold, it falls back to the original query, avoiding risky automatic rewrites. The main parameter is the maximum distance. Lower values favor precision and reduce wrong automatic changes. Higher values increase recall but may introduce incorrect substitutions. This step makes the pipeline conservative and production-friendly. Recap in 3 points. What it is: a search spelling corrector that uses Levenstein edit distance to score candidate words. When to use it: for short user queries and catalogs of thousands of items where small typos are common. One caveat: it ignores semantics and phonetics, so it can miss some errors or suggest wrong replacements if the typo is large. Next step: tune the max distance and prefix length on a labeled validation set and measure both correction accuracy and query latency. That single experiment will show the best trade-off for your catalog. If practical, short IR helps your users. Subscribe and watch the IR videos.